I would like to teach you empirical and molecular formula. To begin with, let's look at what is empirical formula and what is molecular formula. Empirical formula is the simplest formula of a compound. It tells us the simplest ratio in which element exists in a compound. While molecular formula is the actual formula of a compound, and it gives us the actual number of each atom present in a compound. For example, let's take a look at glucose. It has the formula C6H12O6. This is the actual formula of glucose, and therefore it is the molecular formula. Now let's take a look at this. There are 6 carbon atoms in glucose, 12 hydrogen atoms, and 6 oxygen atoms. If we divide through this number of atoms by 6, we're going to have 6 divided by 6, we have 1 carbon. 12 divided by 6, we're going to have 2 hydrogen, and 6 divided by 6, we're going to have 1 oxygen. And this will leave us with a simple ratio of atoms for glucose, which will be CH2O. This simplest formula of glucose is actually the empirical formula for glucose. So the simplest formula of any compound is the empirical formula, while the actual formula is the molecular formula. Now, the molecular formula of a compound is always equals to N times the empirical formula, where N is a multiple. Now, from what we have done so far, C6H12O6, taking a look at glucose, is the molecular formula, while CnH2O is the empirical formula for glucose, and N is a number which we use in dividing all this, and that is 6, which is the multiple. So if you multiply CH2O by 6, we are going to get C6H12O6, which becomes the molecular formula. If it's the first time on this channel, before I proceed, please can you click on the subscribe or follow button. Alright, let's look at some numerical example. Example 1, we're going to be looking at type 1 problem which involve mass composition. A compound contains 50.5 grams sulfur, 49.9 gram oxygen. Find the empirical formula of this compound. We are given the mass composition of the compound, which is 50.5 grams sulfur and 4.9 gram oxygen. Step 1, let's write out the given atoms. We have sulfur and oxygen. Then we'll follow this by writing their atomic masses. Atomic mass of sulfur is 32 grams, while that of oxygen is 16 grams. Step 2, let's calculate the number of moles, which is always equals to mass all over molar mass. So first we write out the given masses. Sulfur is 50.5 grams, oxygen is 49.9 grams. Let's divide through by the relative atomic masses. So we're going to have 50.5 grams divided by the relative atomic mass of sulfur, which is 32 grams, and 49.9 grams divided by the relative atomic mass of oxygen, which is 16 grams. So if we do this, 50.5 grams divided by 32 grams will give you 1.56 moles. 49.9 grams divided by 16 grams will give you 3.12 moles. Step 3. Let's get the simplest ratio. And we'll get that by writing out this number of moles. First of all, we're going to have 1.56 and 3.12. And we'll divide through by comparing, by using the smallest among them. So 1.56 is smaller than 3.12. So we'll divide through by what? 1.56. So we're going to have 1.56 divided by 1.56. And 3.12 divided by 1.56. So 1.56 divided by 1.56 will give us 1. 3.12 divided by 1.56 will give us 2. This implies that sulfur is equals to 1 and oxygen is equals to 2. So the simplest formula of this compound is SO2, and the simplest formula is always the empirical formula. So this is how to go about a question like this, a problem like this. Example 2. Let's look at problem involving percentage composition. A compound contains 64.8% carbon, 13.62% hydrogen, 21.58% oxygen. We have to find the empirical formula of this compound. We are given percentage composition, which we'll be looking at them as if they are what masses. Now, step 1, we'll write out the given atoms: carbon, hydrogen, and oxygen. We'll write out also their relative atomic masses. Carbon is equals to 12 grams, hydrogen is equals to 1 gram, and oxygen is equals to what? 16 grams. Let's calculate the number of moles from the given percentage composition, which is equivalent to the masses. Number of moles, first we'll write out the percentage compositions as mass: 64.8 grams for carbon, 13.62 for hydrogen, and 21.58 for oxygen. Now we'll divide through by their relative atomic masses. So we're going to have 64.8 divided by 12, 13.62 divided by 1, and 21.58 divided by what? 16. So 64.8 divided by 12 will give us 5.4 moles. 13.62 divided by 1 will give us 13.62 moles, and 21.58 divided by 16 will give us 1.35 moles. Step 3, we'll get the simplest ratio, and that will do we get by what? Dividing through by the smallest number. So let's write out the number of moles: 5.4, 13.62, and 1.35. So the smallest number here is 1.35. So we'll divide through by 1.35. So we're going to have 5.4 divided by 1.35, 13.62 divided by 1.35, and 1.35 divided by 1.35. So 5.4 divided by 1.35 will give you 4. 13.62 divided by 1.35 will give you 10. And 1.35 divided by 1.35 will give you what? 1. So that it implies that carbon is equals to what? 4. Hydrogen is equals to 10. And oxygen is equals to 1. So the simplest formula of this compound, in which reply the ratio in which they combine, is going to be what? C4, H10, and O. And this is the ratio in which these elements combine. And that is the empirical formula of this compound. Are you following? Please click on the subscribe button. Example 3. How we calculate molecular formula from empirical formula. Calculate the molecular formula of a compound with the formula BH3, which has a molar mass of 27.7 gram. We are given the empirical formula as BH3 and the molar mass as 27.7 gram. Now, we have known that empirical formula times N is equals to molecular formula. And we have been given the empirical formula to be what? BH3. So times N will be equals to molecular formula. That implies that BH3 plus 3H, trying to calculate the molar mass of BH3, times N will be equals to the molecular formula, which is 27.7 gram, is already given in the question. Now, relative atomic mass of boron is equals to 10.8 grams, and that of hydrogen is equals to 1. So we can get the molar mass of the empirical formula, which is going to be 10.8 plus 3 into 1, because there are 3 atoms of hydrogen, is equals to 27.7 grams. So that if you open your brackets, you're going to get 13.8N is equals to what? 27.7 grams. So that N will be equals to 27.7 grams divided by what? 13.8. And N will be equals to 2. If it's the first time on this channel, before we proceed, please do not forget to click on the subscribe button. Now, empirical formula times N is equals to what? Molecular formula. We have established that. This implies that molecular formula is equals to BH3 times N. So that We have calculated that N is equals to 2. It implies that molecular formula is equals to BH3 will replace N by 2. This implies that molecular formula is equals to BH2 H6 because you multiply that bracket, B times 2 is B2 and H3 times 2 will give you what? H6. Are you following? Let's proceed. Example 4. How we calculate empirical formula and molecular formula. A compound contains 24.27% carbon, 4.07% hydrogen, and 7.165% chlorine. Its molar mass is 98.96 grams. Find its empirical formula and molecular formula. So we are given the percentage composition, and we are given the molecular formula, and we have to find both the empirical formula and molecular formula. So first, we'll calculate the empirical formula. Step 1, we'll write the given atoms: carbon, hydrogen, and chlorine. And then we'll write the relative atomic masses. Carbon is equals to what? 12 grams, hydrogen 1 gram, and chlorine 35.5 grams. Are you following? Step 2, we'll calculate the number of moles. So we'll write the percentage composition as masses. That is 24.27 grams, 4.07 grams, and 71.65 grams as given. Then we divide through by the relative atomic masses. 24.27 divided by 12, 4.07 grams divided by 1, and 71.65 grams divided by 35.5 grams. This will give us 24.27 divided by 12 will give us 2.02 mole. 4.07 grams divided by 1 will give us 4.07 moles. And 71.65 divided by 35.5 will give us 2.02 mole. Step 3, we find the simplest ratio by dividing through by the smallest number, and that is 2.01. So 2.02 divided by 2.01, 4.07 divided by 2.01, and then 2.01 divided by what? 2.01. And this will give us 1. 2.02 divided by 2.01 is equals to 1. 4.07 divided by 2.0 will be equals to 2. Nearest whole number. 2.01 divided by 2.01 will be equals to what? 1. This implies that carbon is equals to 1, hydrogen is equals to 2, and chlorine is equals to 1. This represents the simplest ratio in which they react. So the simplest formula will be what? CH2Cl. And that represents the empirical formula of the compound. Now let's calculate the molecular formula. Molecular formula is equals to N times empirical formula. Don't forget that. And the empirical formula we'll calculate is what? CH2Cl multiplied by N will be equals to molecular formula. So let's get the molar mass of the empirical formula. That is going to be what? C plus 2H plus Cl in bracket times N will be equals to 98.68 grams is given. Now, it implies that 12 plus 2 into 1 plus 3, 35.5 times N is equals to 98.68 grams. So that if you open your bracket, you are going to get 49.5 N is equals to 98.68. Divide through by 49.5. So you're going to have 98.68 divided by 49.5. And N will be equals to what? 2. Now, molecular formula is equals to N times empirical formula. So you're going to have CH2Cl, bracket open, times 2 equals to what? CH2CH for Cl. You get that? So that